So, good morning everybody. Myself Acharya Vishvendra. Let's discuss certain questions based on momentum and force today. So, the question is that a block of mass 2 kg is moving in space such that its linear momentum is given by P is equals to 2t square minus 60 plus 6, and we need to find the first question is initial momentum. So, you put 2 is equal to 0, then you'll get momentum as 6 kg meter per second, assuming that all the quantities here are in SI unit. Then we have momentum at t is equal to 2. You substitute t is equal to 2, so p is equals to twice 2 square minus 6 into 2 plus 6, which gives 8 minus 12 plus 6, which is 2 kg meter per second. Then we need to find momentum at t is equal to 3. So you substitute t is equal to 3, and after substitution you get momentum as 6 kg meter per second. Then there is a question at what time momentum is 0, so you just equate momentum to 0. That will be a quadratic equation, so roots will be this. Since there is negative inside the root, so that means there are no real roots of this particular equation. Next is we need to draw momentum time graph. So momentum is this, we differentiate it, we get 40 minus 60, t is equal to 3 by 2. That means vertex of this parabola will be at t is equal to 3 by 2, and the value corresponding to t is equal to 3 by 2 is 1.5. So that will be a parabolic curve like this, as we know that graph of quadratic equation is parabolic. So next question is at what time momentum increases. So as you can see in the graph that momentum increases from 3 by 2 onwards. So it increases during t greater than 3 by 2. Next question is at what time momentum decreases. As you can see in the graph, momentum decreases during 0 to 3 by 2. So that will be the time interval. Next is we need to find average force during 0 to 2. So average force is delta P by delta T, P2 minus P0 by 2 minus 0. Momentum at 2 is this, 0 at this. So that comes out to be minus 2 Newton. Then we need to find average force during 2 second to 4 second. Using same equation, we find momentum at t is equal to 4, which comes out to be 14. So using the expression F average is delta P by delta T, which is P4 minus P2 by 4 minus 2, which is equal to 6 Newton. Next is we need to find instantaneous force. So we know that instantaneous force is differentiation of momentum, which is 40 minus 6. Next is we need to draw force time graph. So we know that this equation corresponds to a linear equation, and at t is equal to 0, force is minus 6, slope is positive, so it will be like this. Next is when is force positive. So as you can see in the graph, force is positive when t is greater than 3 by 2. So that will be the answer to this particular question. Next is when is force negative. So you can see in the graph force is negative when t lies between 0 to 3 by 2. So that will be answer to this question. Next is when is force 0, as given in the graph, force is 0 at t is equal to 3 by 2. Next is find instantaneous velocity. So we know that momentum is equal to mv, mass is 2. So 2v is equal to p, that means v is equal to p by 2. We substitute the value of p over here, and the expression of velocity instantaneous comes out to be t square minus 3t plus 3. Next question is we need to find initial velocity. So you substitute t is equal to 0, that gives v is equal to 3. Next question is find velocity at 2 seconds. You substitute t is equal to 2 over here. So velocity is 2 square minus 3 into 2 plus 3, which is 4 minus 6 plus 3, which is 1 meter per second. Next is find velocity at 4 seconds. So substitute t is equal to 4, that gives velocity as 7 meter per second. So you have seen that we have solved 18 questions within 3 to 3.5 minutes. So these video lectures are just meant to check your problem solving skills, and it includes questions up to the level of JEE Main and NEET physics. And soon I'll be uploading questions specifically designed for JEE Advanced, as they are more complex, involves multiple processes, multiple algorithms and complex algorithms. But certainly these can prove to be a boon to you for preparing physics for NEET and JEE Main. Thank you and have a nice day.